I've been working in software for close to 20 years. I've worked as a team leader, as a tester, as an architect, as a CTO, as a consultant, mostly in the past few years. I'm going to be speaking about testing in the age of DevOps, which is really a subject that I think is sore for many testers. There's a bunch of fear about it. Um, what I'm going to talk about is the fact that it's actually a very good thing for testers, because DevOps is all about testing. Entry I've ever experienced. That drum stuff, that was amazing. I was like dancing, doing break dance and stuff. That was awesome. Okay, so DevOps, right? Okay. Testing in the age of DevOps. Good morning. My name is Roy. I will begin this. Hi. I will begin. Hi. I will begin this talk talking about my favorite subject. A little bit about myself. My background. As you've heard, I've done a bunch of stuff. I've also managed to fail quite a bit in many software projects, but I've also managed to succeed in some of them. And they say that failure is the best teacher. I am an excellent, excellent student. And today I'm going to teach you some of the failures that I've experienced. And mainly in the past few years, where I was specifically working in the DevOps space, continuous delivery, continuous integration. Although my background is pure development, I'm really deep into testing, specifically unit testing and test-driven development. Yesterday I held a workshop with some wonderful, amazing people from all over Europe. And Dimitris, where are you? Yeah, thank you. Too late. But here's the thing, is that unit testing and test-driven development is just part of that equation that we want people to do. There's another part to succeeding in an agile world, in a DevOps world. And that other part, I believe, is leadership. We want people to actually do the things that we believe are the right things. You can't substitute just technical and throwing tools at people than actually having leadership abilities and people skills to change things. So I wrote a book about unit testing, and then I wrote a book about elastic leadership, which is all about my failures and successes as a team leader and getting people to a place where they're productive and building effective teams. And I'm in the process of writing a third book called Enterprise DevOps, which is a big part of this talk is going to be based on it, but I'm specifically targeting it for testers. Now, even though I'm not a tester full-time these days, I work a lot with testers, and I have a lot of experience working and seeing them in the wild. I've worked in the Fortune 50 organizations, the biggest banks, insurance companies, and I got to see testers when I was working at startups, and I got to see testers when I was working at companies that had 100,000 people working in them. And there were many patterns and anti-patterns that kept happening and repeating. And when we're talking about the world of DevOps, we're going to be seeing that some of these patterns happily go away, but it's up to us as testers to take the initiative and make something good from it. So this talk is going to be divided into three parts. First of all, I'm going to talk about what DevOps is in my eyes. And the reason I'm going to talk about it, about the definition of it, is because if there are 600 people in this room, there are 600 definitions of DevOps in this room right now. And everyone is right in their own small, corner. And what I'm going to try to do is to, first of all, display the presentation and to talk about the fact that there are meta patterns, meta things that connect most of the views. There are common things in the way we view a success in a DevOps space. So you might see a specific set of practices, other people might see a specific other set of practices, but there are things that tie these things together. The second part is going to be about adoption challenges. Because if you are going to experience some kind of a DevOps adoption in your organization, you can prepare to experience some hardship, as you will. for example. This is a form of integration testing in the worst sense of the word right now. Obviously, it's kind of flailing. And the third thing I'm going to talk about is specific experiences and practices that you can see changing in a DevOps world. So, before I actually start, by raise of hands, if you are part of an organization that is currently trying to do DevOps in some way, whether it's misguided or amazing, are you part of something like that today? Raise your hand. Okay. Keep your hand up if you feel it is successful. Okay, it's about 10% of the people who were there. Raise your hand if you think it was not only successful, it was the most successful you've ever seen. Okay, that's, I specifically made it hard. I just wanted to see how high you will go. Okay. So hopefully you'll see some of the things that I'll talk about. You'll be able to connect with it. So the definition. There are so many different ways to describe DevOps. But here's my current set of the way I explain it in a single sentence. There are three main ways that I talk about it. Even though it's many different things, there are some common things about it. At the meta level, DevOps is what modern IT looks like. If we're talking about old IT infrastructure, the old waterfall models and all that stuff, if we're talking about then the modern, what does that look like? DevOps is an example of describing the modern IT and how it behaves. And IT means development and infrastructure and operations and security and compliance. It is the coded business policies. Each business has a set of policies. What is allowed, what is not allowed, how do we deliver software, where are we allowed to deliver that software, to which environments, under what conditions. And we put that thing into code. We put that code in source control, and so we can describe our policies as code. So DevOps is coding the policies of the organization into pipelines. DevOps is the most advanced form of software engineering at scale, because in DevOps world, everyone becomes a developer. Everyone writes a type of code. Everyone uses source control in one way or the other. Most people will start using software development lifecycle ideas and pipelines to create new forms of features, ideas, tests, and stories. The end game for any organization that's adopting DevOps, what they're really trying to do is increase velocity. Increasing the velocity of how fast they can release software so they can be competitive in the market. So if velocity is the end game, DevOps is the blueprint. It's the operating manual. Now, I'm aware, and I believe that DevOps is also the new Agile in many ways, in that everyone uses that word, throwing it around. Agile used to be cool, now DevOps is the cool thing to do. So there's a lot of hype around it, and it's very easy to just say, whatever you did there, you just do it here, you just call it DevOps. You had a Scrum team, now you call it a DevOps team or whatever. And there are many anti-patterns in that, I'll talk about them. But there are ways to succeed in that actually innovate, that actually change something from how we used to define specifically Agile projects or Scrum projects, because this is a way for an organization to behave with all the departments together. Now, the core value of DevOps is the highest priority is to deliver value. So deliver or satisfy the customer through early and continuous delivery of valuable software. The end result is measured in value. And how you measure that value and how you measure the quality of that software, whether you're on the right track or not, is up to us. We can decide what are the metrics that we want to have to decide whether what we're measuring brings us what we're trying to do, and if we're not, we can measure something else so we can achieve a better result. And each project can have a different set of metrics. But there are some common metrics to DevOps. And I'll talk about the metrics in a second, but before that, DevOps is also about flow. It's a kind of a combination, if you've heard of Kanban and the idea of flowing and value streams, moving things from left to right. DevOps is about managing the flow at the organizational level, at the product level, all the way from when an idea is formed in the mind of someone in the organization up until the time that that idea exists at the customer and actually delivering value to the customer. Another way to say it is concept to cash. So it's in the hands of a paying customer and it's actually generating value for them. Key DevOps metrics. Organizations that adopt DevOps begin to think about 4 main metrics, and those metrics also affect the work of testing. Lead time to change. This is the overall cycle time from concept to cash. And the way you measure it is you start doing value streaming. Has anyone here ever tried to do value streaming? Okay. And has anyone here succeeded in doing a full value stream all the way from concept to cash? Okay, none. It's actually a pretty difficult thing to do. Value streaming is the act of taking all the parties that are related to delivering the software. Not only development, not only testing, also security, compliance, project management, everything that's on the way, everything from the point where the idea is beginning, mapping them out and asking questions like, how long does it take you physically to achieve that task? How long are you waiting between those tasks? And what we end up with is a value stream with a set of numbers associated with each task from left to right. Now, that number is the total cycle time. And when we ask those questions, we say, what is the average time it usually takes? Because everything has corner cases. But usually, more than 50% of the time, how long does it usually take you to get the requirements document? How long, on average, does it take you to receive the results of the test? On average, how long does it take to run the tests, et cetera, et cetera? How long, on average, do you wait before you actually start because you have other things in your queue? And so the lead time to change is the main starting point for most DevOps adoptions at the project level, because it gives us a baseline of saying, this is what we're working with. And in some organizations, it can be 8 months, even though they might be doing nightly builds, because the nightly builds that they're doing, that code might be 6 months old. It's like it has been sitting in a branch for 6 months before someone was actually merging that code into the master branch. So counting that time also is included. Another DevOps metric, mean time to recovery. This is a very important change for many organizations, for many IT organizations. Many IT organizations measure a different metric, mean time to failure. How long does it take for us to fail in production? Now, what this creates is a negative force. Because imagine this, if I'm the IT person, the operations person, and I'm measured on how little or how long it takes between failures, my incentive is to minimize failures, and meaning to keep things as steady as possible, which means I'm going to not allow changes to production as much as I can. So that's an inverse requirement from what developers are usually being asked to do, and testers. We need to deliver this as fast as possible. And so there's this clash of incentives between these two main departments. The people who are in charge of the deployments in production and the people who are delivering new value. So changing that to mean time to recovery as the main metric changes that incentive. What that means is, I'm not measuring you based on how long it takes to fail, but on how long it takes to recover. So we assume that failure is going to happen in production, but you're going to be measured on how quickly we can recover from that failure. Which means now we have incentives not to delay changes, but to recover from changes. So either rollbacks or roll forwards, deploying fixes automatically and quickly, or having multiple systems and you just switching the DNS between them. There are many ways to think about how to solve that problem. But what's important is that those metrics, they change the behavior of people in the organization. And this is going to be a common theme in a DevOps world, is that people are the first line of change in a DevOps world. It's not tools. Tools are the last thing that you choose, because the people, the interactions, the value streams, the pipelines are the important part, and everything else revolves around them. change failure rate. When we adopt DevOps, what we want to see is that every time we deploy, there's less and less failures because we automate more and more of it. And we know that the more manual things are, the more likely they are to fail. So automation and automated testing of deployments is a key change that DevOps adopts to reduce this metric. So again, this is a key metric, and when I say key metric, I mean that managers, PMOs, development teams, any kind of technical team will have a screen in their room showing a continuation of those metrics over time to see that the work they're actually doing affects those things. And if what you're doing does not affect those things, it has to affect other measurements of quality that we decide as a project team. But in terms of DevOps adoption, this is how we know we are on the right path, that we're moving in the right path. Release frequency is obviously the most obvious one of them. How quickly can you release software? And the goal here is to not be the bottleneck of the organization. Usually organizations want to release faster than what IT can deliver. But it takes us 3 months to do the testing cycle and test us this to do the compliance and whatever and whatever. So the IT organization decides when is the minimal amount of time between release frequencies. They are the bottleneck. When we adopt DevOps practices, we can deploy and we can deliver things much, much faster. So much faster, in fact, that we become too fast. And that's exactly what we want. We want the business to start telling us, hold on, don't release just yet. Release should become a marketing event, not a technical event. We can deploy multiple times, but a release is decided by the organization. It could be every 3 months, could be every 2 weeks as they make the marketing materials. It could be something else. But we should not be the bottleneck in that pipeline. So in short, Agile is a combination of multiple approaches. The Agile and Lean and Kanban and continuous delivery approaches. On one hand, it automates infrastructure configuration, development, testing, and deployment into a delivery pipeline. It automates all those things, but at the same time, it increases emphasis on collaboration between different teams, different skill sets, and creating teams that share the same purpose. So no longer should you have a separate team of testers where you throw things over the wall. This is standard Agile testing at this point, but testing should be part of development. It's going to be very hard to tell the difference between a tester and developer because both of them write tests. There is also a big emphasis on crossing borders between different skill sets. So if you see here infrastructure, development, quality, operations, security, and compliance, all these people have to collaborate together to make a pipeline successful. So the anti-pattern that usually happens in larger organizations is that a team wants to do continuous delivery and everyone is on board. When everyone, I mean the technical folks, the QA, the developers, they're like on board, yeah, let's do it. What about security? Oh, they're never going to listen to us. Okay. What about the compliance? Oh, they're never going to listen to us. So here's what we're going to do. Hush, hush. We're going to build our own environment. And in that environment, we're going to do continuous delivery. No one will know in the organization. It's a big organization. And then we're going to do continuous testing and test-driven development. We're going to do automated and smoke testing and acceptance testing. And then we're going to deploy as far as we can inside the organization, which goes about all the way to the next level of IT department. So you can usually deploy up to a specific environment, and from that moment on, the shield is gone. From that moment on, there's a whole different department that's in charge of taking what you have delivered, which could be binaries and code. But because there is no communication between those two departments, because there is this lack of trust, they have a completely separate process of taking all that stuff that we've worked so hard to automate and do continuous stuff on, and then they break it. They recompile that stuff and they test it maybe manually and they deploy it manually. And the people who worked on all that in the bubble here are like, I can't believe they're doing this. Oh no, this is so horrible. Well, I guess that's life. Okay, let's just continue. But that creates a set of huge problems. That inconsistency between the environments. Something happens in production and you cannot recreate it here because production looks completely different than the environments that you have locally. That mistrust, the inability to test with the exact same conditions as production produces fear. So then, because it takes such a long time to get all the way to production, people are really trying to make sure that the batches become bigger because there's only one chance every month for that stuff to appear. So it really has to be really, really good instead of working in small batches. It really has a negative spiral effect. So collaboration is key, and it's one of the hardest things to do, which brings us again to leadership and the leads of those teams and management that has to support this. Continuous delivery rules are a big part of the game here when we're talking about DevOps. DevOps and continuous delivery are really good friends. Continuous delivery is basically the operating model of a pipeline. And there are several simple rules to continuous delivery. We want the process for releasing and deploying to be repeatable and reliable. So if I'm deploying it here, I'm going to use the same script to deploy it to all different environments. And if I cannot do that, something is wrong. What do I have to change to be able to do that? Automating everything down to bare metal. That means creating the environments in a way that's fully automated, fully repeatable, and in source control. So that if I wanted to recreate a bug in a specific version of an environment, it should be really, really easy to recreate it. And I've seen many organizations just fight with just trying to be able to recreate something that happened in an environment and not able to do it for weeks. And the frustration from everyone involved is just, just painful to watch. And everyone assumes there's no way to change it, but that's not true. So keep everything in source control, and if it's difficult, do it more often. Means find a way to make it less painful. Don't avoid it, because that's an example of a bottleneck. Done means released. Done does not mean I handed it over to the next team. Building the quality in means that we don't use a waterfall approach, but we build the quality and the measurements and the regressions as part of the development cycle so that we don't have to wait to get the feedback later on. Everyone has a responsibility for the release process. This is very important. There is no DevOps team just responsible for the release process. Now, technically, in an adoption stage, you might get that temporary team that's creating those pipelines and temporary processes. But it's an anti-pattern to keep that team alive as a separate team just in charge of the release. And the reason is they become a bottleneck. They become that one specialized bus factor. Who knows what a bus factor is? It's not many people. A bus factor is how many people have to get hit by a bus for the team to stop working. Okay? A bus factor of 1 is the worst. And if you think about it, all of you, in all of your teams, you have at least a couple of bus factors. That one person who knows how the build works. One person who knows how the database operates and the connection string. The one person, if they went on sick leave tomorrow, you would be in big trouble. So if you feel you cannot personally go out and have a vacation without keeping your phone turned on, that's an example of a bus factor or a bottleneck. Well, what we are trying to do, we're trying to avoid bus factors and bottlenecks, and the way to do it is by sharing information, sharing knowledge, cross-training, which is kind of scary because it means now testers are going to have to learn more skills. Not a bad thing. IT folks, operations folks will have to learn new things too. Development folks will have to learn new things. Compliance will have to learn new things. Everyone will have to learn something in order to meet in the middle and have a shared team. So this is not a process that takes a week. You can't take it and you can't go to a Scrum Master course and return after 2 days and say, it is solved, I'm here. You cannot do that. Those things take months and sometimes years. And the way you do them is you do them with pilots, one project at a time. And then you create that knowledge of how does it work in my company. Build binaries once is an example of some practices that we adopt to be able to live up to those principles. No more multiple compilations. Having the same mechanism, the same scripts for all deployment. Smoking test the deployment. So in every environment, we actually run automated tests. And stopping the line, so not allowing deployment or anything else to continue if something is red. That means if you have inconclusive tests that are somewhat red and somewhat green, that doesn't work in a DevOps world. You have to be conclusive. So how do you deal with that kind of thing, for example? You decide that if we have under 20% failing, then that's actually green. So it's not a person that decides those things, it's the pipeline that makes an automated decision. And that becomes a quality gate. And you can increase or decrease the quality gate, but it's either passed or failed. There's nothing in the middle. An example of a pipeline. The lines represent different versions or different check-ins into source control. And they trigger the different stages at the top. And the different stages, they change in an organization and in a project. So these are some common things. We have a commit stage, when the check-in stage, which usually creates, compiles things, creates binaries, and runs fast unit tests. We have acceptance, performance, UAT, and you'll notice that you can move automatically or manually between stages. And as you build and you adopt more and more DevOps practices, you can basically decide what is the manual gate that you choose. And as you become more and more mature in the pipeline, you can create more things to be more and more automated. There are a couple of more important pieces of information here. Notice that a failed build, a failed acceptance test has stopped the line. It doesn't actually go all the way to production in this case. But then the next version does. So instead of fixing the previous version, we fix it in the next version. So it's the next check-in that fixes that problem, and then we can go. So in the DevOps world, we work in small batches, and every check-in is a potential candidate for a release. We can decide whether to release it or not, and the way we decide is only one way. Did it pass all the stages of the pipeline? The stages of the pipeline represent my policy. They represent my organizational policy. What does it mean to be done in terms of that stage? It has to pass performance, okay. Oh, maybe it has to also pass compliance automated tests. Okay, I'll add a stage for that. So your pipeline is a living, breathing organism that you keep watering and changing, and it actually is a development project. And in that regard, your pipeline should also be tested because it's a piece of code, it's a script. And testing pipelines is actually pretty easy because they're pipelines. You just run it on different sets of environments and you see how long it takes to achieve something, or you see the results. So instead of deploying to production, you can deploy to non-production and see that your pipeline can actually do it. But the pipeline itself serves as a test for each stage. And each stage tests something that we care about in the application. So if the pipeline is king in a DevOps world, the organization is centric around the pipeline. It doesn't make sense that only development code happens in a pipeline. Also infrastructure code. So here's an example of the beginning of a pipeline where you have two adjacent teams. The top one is development team and testing, and the bottom one is the infrastructure team. And what happens is that during the commit and the check-in, the code is built and compiled, but also at the same time, the infrastructure code is built and compiled. That is the latest version of the infrastructure that we need to run our application. So instead of there being an environment ready to run, just waiting for someone to deploy to it, the environment gets created as part of the pipeline. The environment is a just-in-time environment, an ephemeral, temporary environment. And the environment is based on code that was written to create infrastructure as code. So you could use Chef or Puppet or a bunch of other stuff like Ansible, etc. And it runs in parallel And when it's ready to be deployed to, the application gets deployed to that infrastructure instance somewhere in a private or a hybrid or a public cloud. And then a bunch of tests run on that deployment. And when that pipeline is over, the environment can get shut down. So the environment, the infrastructure is also a piece of code. There are a bunch of tools that you can use at each part of this. It's pretty scary to look at the amount. This is really just a partial list of choosing what tool do I need for which stage. What I'm here to tell you is that this list of tools that you're currently taking a picture of is the least important part in your pipeline. Because until you've actually designed the pipeline and the value stream that you really need to have, you should not be choosing tools. Because if you choose the wrong tools that do not support the pipeline that you need to have, you're not going to be able to build the pipeline. And I've seen quite a bit of organizations that have made the choice in tools way before they started anything to do with pipelines. They've already committed sometimes millions of dollars to buying really expensive software that is almost impossible to automate, impossible to use through a command line, impossible to have an API through. And so they spend all this money and now they can't use it. So what they do is they spend even more money on hacking it and getting it to do the thing that they need to do instead of not using it and using something much simpler, sometimes open source, sometimes not open source, but simpler and easier that will actually support the pipeline. So one key important information here is the tools are chosen last. The first rule is create the value stream. Then you design the pipeline that you want, and then you decide which tools support the actions that you want in the pipeline. Oh, I need this type of deployment. Oh, I need this type of testing. Oh, I need this type of source control. I need this type of binary repository. Okay, now let's go and choose the tools that support those scenarios. And then you're in a much better position. Now, what do you do with a company that's already invested? Well, it's a political journey. And sometimes there's not a lot you can do. You have to sometimes let people feel the pain until they get the motivation to change. Sometimes you cannot say things internally, so you call a consultant to say what people are afraid to say. You know what consultants are paid for, right? They're paid for getting fired. They're paid for saying things and then people boot them out because they said the right thing. But at least it got said. So the truth has to be somewhere. So I started talking about some adoption challenges. The biggest adoption challenge that I've seen organizations have, because everything is about testing, we can add a bunch of automated tests all over the pipeline. But the biggest factor is policies. So I've been to so many projects, and tell me if you've been there before. You go and you're in a project and you want to do continuous delivery, you want to do continuous deployment, and everyone is on board until the people who are in charge of actually getting to production get into the picture. And everyone goes like this and they go, hold on. Listen, buddy, not gonna happen. Not on my watch, on my dead body. You will never do this automatically. What are you, crazy? You want to deploy automatically to that system that handles these amounts of clients and all that money? What are you, insane? No, we have to do it manually. We have to do it manually in an error-ridden way. We have to do it manually in a way that's not repeatable and then check it very, very slowly. That's the right way to do it. Why is that the right way? Because that is the policy in the organization. So to change those behaviors, it will not matter how much that person might want to change that. You have to go to the people who make the policies. You go to the decision makers, to the compliance teams, and to the security teams, and you sit with management and you decide to create a temporary agile policy for continuous delivery on a pilot project. And that will be your beginning of a test. Can the organization create a policy that enables continuous delivery? What would that entail? And you sit and you work with them. Sometimes it takes a few months to create the policy that the organization can live with. And until that policy is not in place, you will never be able to get that pipeline all the way to production. Sometimes it's literally sitting with lawyers in the company, what is allowed and what is not allowed. Wait, do you want to deploy to a public cloud? No, we can't do that. Or we can do that, but you have to get all these automated processes that turn all the user identifiable information into encrypted during transport. So we get through all these hurdles, but they will tell us what we need. And usually, if you have enough management backing, compliance is not going to say no. They're just going to say, yes, if you do all these things. And then you ask, if I do all these things, you will allow that to happen automatically. Yes, and if you do this and you give me an audit trail, which is the easiest thing to do in a continuous integration build, to have an audit trail of everything that exactly happened, then yes, I will allow it. And organizations, one by one, they fall into that. They are allowing it. But the trick is to start changing things from the top. We cannot only adopt DevOps from the bottom up. It will work up until only a specific amount of bubble. Okay? So one of the things we have to do when we do DevOps adoption is to decide that we do it from two places at the same time. One person goes from a technical standpoint, and another person goes and talks to management, and that happens continuously. Management creates that umbrella of confidence so that the team can actually have time and try to do these things and have the permission to go and talk to all the other parts of the organization. Did I say DevOps was easy? It is hard because it's all about people and politics and changing the way that things are currently existing. So it's very easy to go back and say, you know what, screw this. I don't have time for this. I'll just, I'll load up a Jenkins instance and I'll run that stuff. You're going to be right back where you started. And in a year, you're still going to be feeling the same pains. So even though you're running internally, you're still going to feel all the pain of the misguidance and the misconfiguration and the miscommunication between the different departments. And at the end of the day, you will not change the core metrics that we talked about. You will not change the release frequency. You will not change the amount of failures in deployments. Okay? We will not be able to change those things because we are not affecting the pieces in the value stream that actually change those things. The same problems still exist. But we're here to have fun, so you have to, don't be sad. So I said the biggest DevOps battle might be about policy. Here's another DevOps battle that happens. In really large organizations, you don't have one pipeline. You don't have one product. You have multiple products. And they depend on each other. You want to deliver something, you change something, something else breaks. That thing breaks, something else breaks. Follow, the rabbit, follow the ball. Where does it go? So sometimes in large organizations, another thing that happens, just tracking down the right people and the right dependencies for a project to build the pipeline. For example, I deploy something, but now I have a bunch of dependencies. I have to connect to these web services. I have to connect to all these other places. Those are dependencies. They're different teams. Now I have to go and talk to those other teams. Oh, they have their own dependencies. How do I make that pipeline work? And sometimes the answer is that you build pipelines of pipelines. So imagine that if I wanted to have an application deployment, but I want to know if I broke your deployment. Your application that depends on my database, for example. I will run my pipeline, I will deploy to a staging environment, and then I will run your pipeline to test with my new deployment, your last known good. And if that pipeline still works on the environment where I just deployed my pipeline, then my pipeline continues and everything is okay. A pipeline that invokes other pipelines. The inputs and the outputs are actually other projects. I think we only have like 5 minutes left, am I correct? Okay. And there is one extra thing to do with the adoption phase, and that is managers are absolutely sure that this is what happens during the adoption phase. You start here and you finish there, and then that's it. So then the real trick is to teach people that adoption happens in very small increments, pilot by pilot by pilot, project by project, and slowly you eat the entire elephant. I don't know who came up with that analogy of eating an elephant, but anyway, you explain this to managers, and you get these faces. Absolutely. Yeah. Small batches. Absolutely. And then they go and they hammer out the entire adoption process. Everybody DevOps now, and everybody's just trying and charging and hurting, and they just want to kill themselves. Just stop it, please stop the pain. So this is what happens. They start, and then that pain happens. There's panic. Then there is a return to the previous normal. If we don't pay attention, people abort the process. There's too much pain because you're taking on too many things at the same time. The adoption happens in small scale and over time. You have to have a success factor. So you cannot choose projects that are too big. You cannot choose projects that are too small. And you cannot choose projects that don't matter to the organization. 2 minutes? 1 minute? He's just saying yes. Okay, and I think last but not least, before we finish for these last few minutes, I want to talk about some recommended books that you might be interested in reading. There is a great book called Testing in DevOps, or a practical guide to testing in DevOps. It's actually a Lean Pub book. Really good book. Someone recommended to me yesterday. So I read it. It's actually pretty short. I read the entire thing. A really nice book. And it covers a lot of the stuff that we have actually talked about today in some way. And he talks about it from the point of view of the tester. If you want to understand continuous delivery to the letter, Continuous Delivery by Jez Humble is a great book. It's a big book, but it's the Bible that we can use to learn. And the DevOps Handbook is a small book that talks about the organizational level, a very high level of adoption and patterns. So if you want to give a book to your manager to read, the DevOps Handbook is very easy to consume, doesn't take too much time, big font. Okay. And with that, I want to thank you for your time today, and hopefully, as I say to everybody, may you fail fast and often. Thank you very much.
I think you really enjoyed the speech of Roy, and the very good thing that you can come and dance with Roy these robotic moves and ask questions. That's correct.
Yeah, I'm going to be here. Do we have time for questions now? I'm going to be here after the talk. I'm going to be standing around looking for a beer, so you can come and talk to me.
Yeah. So, now we split into 4 holes, and be kind to leave a feedback about this wonderful speech Roy gave us. Much applause.